For thousands of years, one of the biggest mysteries about us, about our species, has been the origin of language. But what if a crucial clue wasn't found in some ancient fossil or dusty artifact, but was actually buried deep within our own DNA? That's the central question, right? Sure, other animals communicate, but human language, it's a whole different universe of complexity, creativity, and just pure abstraction. How did we get this incredible power when our closest relatives didn't?
And believe me, the theories have been all over the map. Did we start by gesturing and then speech came later? Was it always about our voices? Or, as some pretty interesting theories suggest, was it all driven by the crazy demands of raising our uniquely helpless babies? For centuries, this was all just speculation.
But then, right at the turn of the millennium, everything changed. Scientists found a real, concrete piece of evidence that seemed to point to a single genetic key to our most human trait. So our story doesn't start on a vast evolutionary timeline. Nope, it begins with a medical mystery that unfolded within just a single family. Let's talk about the KE family. For 3 generations, this really puzzling disorder ran through their family tree, affecting about half of them. It was clearly genetic, and it specifically and bizarrely targeted their ability to speak and understand language. The condition is known as developmental verbal dyspraxia, and the symptoms were incredibly specific. Now, this had nothing to do with intelligence. It was a fundamental problem with coordinating all the complex muscle movements you need for speech, and even for processing the words they were hearing. And this is what led to the huge breakthrough. After years of really hard work, researchers pinpointed the cause. A tiny error, a single-point mutation, like a typo in one word in a giant library, was responsible. And the gene where they found it, they named it FOXP2. Well, you can guess what happened next. The media went absolutely wild. This very complex discovery got boiled down to a simple headline. It was crowned the language gene, the single switch that supposedly made us human and gave us poetry. But come on! In biology, is this story ever really that simple? Of course not. Finding the gene wasn't the end of the story, it was just the beginning. And the real nature of FOXP2 is so much more fascinating than that simple myth. To really understand what's going on, we have to kind of zoom out and look at how evolution actually works. And this brings us to this incredible field called Evo-Devo. Evo-Devo is basically the study of how evolution tinkers with the recipes of life. And what it shows us is that nature is super resourceful. It doesn't often invent brand new genes for new features. Instead, it reuses and modifies an ancient genetic toolkit. And there's a perfect analogy that helps explain how this works. It involves another gene, called PAX6, which you can think of as the master gene for building an eye. So get this, the PAX gene is found in both flies and in humans. In a fly, that gene flips a switch that says, build an eye, and the fly's blueprint makes a compound eye. In you, that exact same gene flips a switch that says, build an eye, and your human blueprint builds a camera-style eye. The switch is ancient, but what it builds depends on the rest of the plan. This amazing concept is called deep homology. Which, of course, brings us right back to our mystery. If FOP2 isn't a build language switch, then what kind of fundamental switch is it? What ancient process is it actually in charge of? Well, to find out, we need to look at where else FOXP shows up and what it's doing in other animals. And the answers, trust me, are pretty surprising. Okay, so scientifically, FOXP2 is what's called a transcription factor. A good way to think about it is like a foreman on a construction site. It doesn't lay any bricks itself. Its job is to run around telling all the other genes when to turn on and when to turn off. And its main job site, a part of the brain that's absolutely crucial for learning and automating complex movement. And here is where we can see that deep homology idea in crystal clear action. In us, FOXP is involved in learning how to speak. In songbirds, it's essential for learning to imitate another bird's song. In mice, it's used for learning all kinds of complex motor skills. Do you see the pattern? The underlying process is always the same: sensory-guided motor learning. And we've got direct proof of this. When scientists experimentally lower the amount of this gene's protein in a young zebrafinch's brain, that bird just can't accurately learn its father's song. It tries, but it sings this garbled, inaccurate version. Now, this type of learning, vocal production learning, is actually incredibly rare out there in the animal kingdom. It's not just learning to use a built-in alarm call in a new situation. No, This is hearing a new sound and then actively modifying your own voice to match it. That's what we do when we learn to talk, and it's what songwords do when they learn to sing. So, if the basic genetic toolkit for vocal learning is shared, what is it that makes human language so special? This means we kind of have to rebuild our whole understanding of what language even is.
So the key is to stop thinking of language as one single thing. A linguist named Charles Hockett had a great idea. He deconstructed it into a list of design features. And for a long, long time, we just assumed most of these were ours and ours alone.
But the more we study animals, the more we see echoes of these features everywhere. Social learning of calls? Check. Songbirds do that. Combining sounds to make new meanings? Some monkeys do that. Calls that refer to very specific things? Yep, vervet monkeys do that. Even planning for the future? We might even see hints of that in some birds. The building blocks are out there.
And all of this leads to a really profound conclusion. The evolution of our language probably wasn't some lightning strike of pure divine invention. It was a classic Darwinian story of descent with modification, taking an ancient toolkit for motor learning and applying it to our voices, all happening in a brain that was also evolving incredible new social and cognitive skills.
Which leaves us with a final, fascinating thought to chew on. Maybe the story of language isn't about a magical gene that made us human. Maybe it's about how evolution took an ancient shared blueprint for learning and, just in our lineage, performed the most stunning renovation, building the most complex and beautiful structure on Earth.